Just recall from the last example we did that the steps for using the method of distribution functions to find the PDF of u, which is a function of y, is to first find the CDF of u by integrating the PDF for y, f of y, over the region where u is less than or equal to some number little u, and then we take the derivative to get back the density. So we're going to apply this to our next example, which is 6.3.2, which is one of them from the text. We have a PDF of f of y where it's y between 0 and 1, 1 between 1 and 1.5, and 0 everywhere else. And we know that the supplier's profit is a function of y, which is 10y minus 4. We want the PDF of u first, and then we'll use that to do some things with expected value. So the first thing we want to look at is finding our CDF for u. First, let's transfer our bounds and see what these would mean for u. So if I plug 0 and 1 into this function 10y minus 4, the first set of bounds for y is going to transfer to negative 4 less than or equal to u less than or equal to 6. And if I plug the 1 and 1.5 as the bounds for y into this function for u, I'm going to get bounds for this second chunk of 6 to 11. So when we look at finding our CDF of u, this is defined to be the probability u is less than or equal to little u, and u here is 10y minus 4. And we have the distribution of y, so let's isolate y here. So this is a probability that y is less than or equal to, if we add over the 4 and then divide by 10, we get u plus 4 over 10. So what we need to do is think about integrating to get the distribution here where we know y is less than or equal to u plus 4 over 10. When we're in the range for u between negative 4 and 6, what we're going to be doing here, what this is going to equal, is we're going to integrate from the lower bound of y of 0 up to the u plus 4 over 10. And in that chunk, our PDF is y. So we get 1/2 y squared, and we're plugging in u plus 4 over 10 and 0 for y. So we get 1/2 of u plus 4 over 10 squared, and then minus 0, and this will be equal to u plus 4 squared divided by 200. Now remember, this is a CDF, so we're accumulating probability. So what happens is we keep accumulating probability up to this upper bound here of 6. And then at that point, we're switching gears and we're looking at the second chunk of this PDF and at what we would get from that. So we want to make sure that we tack on what we've already accumulated. So when we're looking in this range here from 6 to 11, which is the second chunk, we have already accumulated the probability we've got up to 6 plus 4 squared over 200. Okay, because once we've hit this 6, if we plug in 6 here, that's how much probability we already have. So that's the probability already accumulated. Okay, then we keep accumulating more probability according to integrating our new chunk, which is 1. And now what we're doing is we're starting at 1 and we're going up to the upper bound. So remember, we were looking at u plus 4 divided by 10. This probability already accumulated is 10 squared over 200, so that's 1/2. And then what we get when we integrate this is y, and we're plugging in u plus 4 over 10, and we're plugging in 1. So we get 1/2 plus u plus 4 over 10, and then minus 1. And if you get a common denominator for all of this, you'll get u minus 1 divided by 10. So what we want to do is write that all out together. So what we have found is that our CDF, we always start off at 0. So we're at 0 whenever u is less than negative 4. Once we get to negative 4, we start accumulating probability from negative 4 up to 6. And we're doing that with that first chunk we found, which was u plus 4 squared divided by 200. Then we start accumulating probability according to u minus 1 over 10 when we're from 6 to 11. And then anywhere over 11, we are at our total probability of 1. You can verify that at the value of -4, so this cutoff here and here, these are both at 0. This is at 0, this is at 0. At the value of 6, these are both at the same spot, this one and this one. They're both at 1/2. And so this stays continuous throughout the whole thing. So now what we do is take the derivative to get our PDF, little f of u. So what we have, if we take the derivative of the u plus 4 squared over 200, is we bring the 2 down. That will drop it to 100 in the bottom, and we'll just have u plus 4. So u plus 4 over 100. Take the derivative of u over 10, like minus 1/10, and that will just be 1/10. And then this is just 0 everywhere else or otherwise. And you could verify that if you integrate u plus 4 over 100 from -4 to 6, and then also integrate 1/10 from 6 to 11, and total those up, you should get a total probability of 1. So that was the answer to part A. I will do the other 2 parts in another video.